everyone. Thanks for taking out your time and being present in this meetup. I am Karan. I work at Zerodha. My primary interest is in monitoring and observability systems. I started my journey in DevOps about like 1 year back. Prior to this, I was doing backend and front-end programming in Golang and Python. So this talk is about Victoriametrics and how I used Victoriametrics for long-term Prometheus storage and my experience and my journey on setting up monitoring for like multiple Kubernetes clusters using the standard monitoring stack we had. So prior to migration in Kubernetes, we had normal EC2 VMs and we used Prometheus Grafana stack for monitoring. So we wanted to utilize the existing stack. So I'll show how start presenting my screen. One sec. Um, is it visible? The
Yeah, we
screen?
can see your slides. Yes.
Yeah. So I'll give you a bit of context. We had monitoring, so we had multiple Kubernetes clusters to monitor, and we wanted a consistent monitoring infra, like monitoring stack for each one of those clusters, which are like spread across multiple availability zones, multiple regions, all of that. So, and all these Kubernetes clusters, they generate like time series events, like 10,000, thousands of time series events every second. So at current scale, we have around 60, 65 billion time series in our Victoriametrics cluster. So we wanted a solution which could handle billions of time series events as well. And it should be easy to operate and cost effective. So this was one of the key points that we wanted a solution which fits into our existing solution, and not just that, but also it's easier to manage and operate in the long term. So we don't have to spend more time
Uh,
on just maintaining the monitoring infra. We
Hey,
just
Karan, quickly,
use, yeah,
uh,
yeah,
there's a
yeah.
background noise from your end. Maybe you can shut the door or something.
Uh,
Or
One second. Okay.
yeah,
Okay, sorry for the inconvenience, folks. I think Karan is handling the noise at his end. Just bear
Mhm.
with us for a second.
Is it better now?
yeah, it's better. Please go ahead.
Okay, okay. So, yeah. So before jumping to remote storage, first let's talk about what the default storage model of Prometheus is. So Prometheus stores data on a single file disk with it's divided into two parts. One is the write-ahead log, which is so that this log is present so that in any case of memory crash or anything, if Prometheus crashes, the metrics are not lost. And the second is the chunks data. Prometheus batches these chunks like in 2 hours time period of data, and it stores them on the disk. So every time series sample that you see is in present in one of these disks, but these are just stored on a file system. Now, we have some limitations in a single file system, which is first of all, if you are storing all the metrics in a single disk, you are prone to hardware failure or disk corruption, or not just that, even if the node goes down, the Prometheus metrics, the data is unavailable for that period of time. The second problem we get in single file disk access is we can't. It's very difficult to have concurrent read-write access to a single file system. The application has to take in the uh, all those uh, all those complexities that come in within to accommodate for a concurrent read-write access. And the third is you cannot basically replicate this data to to have multiple replicas. because Prometheus is not designed in a way that it can have a master slave kind of replication, all of that. So these were the challenges that we were faced with. Firstly, the single disk that we mentioned, and now if we have Prometheus metrics across our clusters, now this all of these challenges just multiply into that many clusters. So if you have to manage storage in each Prometheus cluster, it becomes a very uh, operational nightmare kind of situation that every EBS backing you have to take snapshots and you have to consistently monitor those disks and all of that. The before jumping to remote storage, we also had an option in taking a look at federation. So Prometheus federation is basically a concept where, let's say you have a global Prometheus setup. That Prometheus will basically scrape the metrics from other smaller Prometheus metrics. Now, the core concept behind this is that your Prometheus will be co-located with your infra, and it will have all of the minute metrics, but only the metrics that make sense at the cluster level will be exported. But to accommodate all of that, it turned out to be difficult. Why is that? Because we wanted a single source of truth. We wanted a global visualization for our metrics. So we wanted to see all of the metrics, and we wanted to join the queries from one cluster to another cluster. So all of that becomes very complex with federation, because at federation you will not have the complete set of data. You'll have only a limited set of data that you choose to export at the cluster level. So that's why we didn't go ahead with Prometheus federation. So the next option was the remote rewrite API. So Prometheus provides this remote storage integration. It's basically a set of APIs, and other systems can develop systems which can talk to this API and store the data. So when Prometheus stores the data in disk, it also makes a call to this remote write API endpoint, and that program is supposed to take care of handling it however it wants to. So this is the core concept that the good advantage of this is that even if your remote endpoint is down, Prometheus will still continue to store the data in your local disk. So as soon as the remote endpoint comes back online, it will just start syncing the metrics from the last point it had lost connect with. So just a minor thing to notice there is that your CPU and memory consumption will increase a tiny bit if you choose to enable this remote write API. Now, we want a remote write API. We are clear about why we need remote storage. But before that also, we'll just talk why we need multiple Prometheus and why can't we have just one Prometheus to monitor everything. So the drawbacks of that is that if your single Prometheus goes down, then you're monitoring for entire infra across the AWS regions, across your data centers. That becomes a single point of failure basically. And apart from that is that since these Kubernetes clusters, if you run something like kube state metrics, which is basically a program which gives Prometheus metrics data of each Kubernetes resource, you will see events in like 10, 20,000 every second from this cluster going out. So you have a very uh, likable possibility that you will end up overloading one single Prometheus, and there's no other way but to vertically scale this up, as we saw the problems in the disk as well. So so now let's talk about remote storage. Basically, we have two methodologies that remote storage you can basically do. One is the fan out, and one is the centralized. So I want to just make something clear that Thanos doesn't use the Prometheus remote write API. It uses its own sidecar mechanism. But Cortex and Victoriametrics, they both use the Prometheus read write API. So fan out would look something like this. So you have on the left hand side, you can see multiple Prometheus instances are there, and Thanos sidecar is running on each instance. If you have to connect Grafana and visualize all of them together, you basically have a component called Thanos Query, which Thanos Query pulls the data from two set of data basically. One is the data stored in S3, which is every 2 hours, Thanos basically uploads a chunk data to some object store. And one is the live data, which is the recent data, which the sidecar only returns. So query component is supposed to aggregate and sort of give you the finalized view. And you basically have to run all of these sidecars and components. The other methodology is central store, where this is something like Victoriametrics, where you connect the remote write, the where you give the ingester endpoint as the Prometheus write API endpoint, and it just starts dumping data to it. So when you connect Grafana to it, you will basically connect the query front to Grafana, and since it understands the Prometheus querying API, it's basically a drop-in replacement for Prometheus data source in Grafana, as we'll see later. So I just want to dive in a bit more on the choices I made with Thanos and Victoriametrics. I'll not consider Cortex here because the Cortex I dropped out early off in my evaluation criteria because it required me setting up a NoSQL database, like something like Apache Cassandra or Google Bigtable or DynamoDB. At that point of time, I didn't want to get a bit slowed down by the operational effects or the operational complexity of Cortex. So I'll just leave that here in the comparison, and we'll just focus on Thanos and Victoriametrics. So firstly, operation. This we already discussed that Thanos uses sidecar versus Victoriametrics uses standard APIs. Performance. So performance of Thanos in terms of ingestion is pretty good because it uses S3 as the remote backend. So it has a good durability, good scalability. In terms of Victoriametrics provides all these services as a shared nothing architecture. So if you run VM insert and VM storage, basically VM insert is supposed to handle the ingestion part, and storage is handled to so storage is meant to handle the storing on the disk part. So if you have any performance issues or anything, you can basically increase the replicas of these two services. Apart from that, reliability. So if we uh, in Thanos, if you end up rebooting your Prometheus or uh, you don't have the disk backing in Prometheus, you have the likelihood of losing up to 2 hours of data as it's not uploaded to S3. But in Victoriametrics, it's not like that. Since Prometheus continuously talks to Victoriametrics every second, Victoriametrics stores the data in its EBS or disk, whatever. And the one key point is that Victoriametrics doesn't use any WAL. It uses something called a sorted string table, where it doesn't need to so the limitation of WAL is that you need to call fsync on your data, and fsync tends to slow down your ingestion capabilities. But sorted string table uh, uh, bypasses all of that, and it gives much better performance than the fsync method. So there's that. Next thing we have comparison with the querying aspect. So if you so like I talked about, Victoriametrics is a standard drop-in replacement for Prometheus data source. So if you have to connect a Victoriametrics data source, you just connect it as a type Prometheus, and it works out of the box. But in case of Thanos, you connect the Thanos query component, and but that is supposed to get data from multiple sources aggregated. So the performance implication of that is that if one of your Thanos sidecar is slowed down due to some Prometheus overload, or if there is a outage in some availability zone, you will get impacted by your query performance. In case of Victoriametrics, the same is true, but Victoriametrics will most likely run in a same AZ or same or even if it's in multiple availability zones, you basically have full control on what components you are running, and you don't have uh, problems where if Prometheus is slowing down, then your query performance is also impacted. This is because Thanos is a sidecar with Prometheus, so it's basically your being affected by Prometheus performance as well in your sidecar. And scalability, yeah, scalability, if you want to add more querying performance, you just increase the more number of query and store gateways so that it pulls the data faster. And similarly, it's true for Victoriametrics as well. And the third is cost. So storage wise, S3 is pretty cheap. It's cheaper than EBS, as you can see. But one thing to note is that Victoriametrics, in its benchmarks, it has shown that it uses 10x lesser data compared to the open time series database format, which Prometheus and Thanos both use. So Victoriametrics regularly compacts the data and regularly performs some disk compaction on those chunk blocks. So you end up spending uh, lesser even if S3 is cheaper, because it's like you're saving 10x of the disk space on the same kind of data. And network in S3, as you know, or any kind of object store, you are charged for the external, like all the data requests, all the network bandwidth as well, apart from all the networking that you have to spend across availability zones. Same is true in Victoriametrics, but minus the S3 or the GCS part. So Victoriametrics, like we discussed, these were the reasons I went ahead with Victoriametrics. Although it was still in alpha phase at that time, we still went ahead with it and decided to give it a shot in one of our test clusters. Uh, a few more things Victoriametrics gives is that it has something called as MetricsQL, which the author claims it's a extended PromQL. But there are some PromQL queries that I'll like to mention that they won't run on the standard PromQL. So the author decided to rename it to MetricsQL, so there's no confusion. Apart from that, there's a improvement in the histograms. So if you have ever created a matrix exporter using Golang, Prometheus client library, you can see that you have to specify the buckets while defining the histogram in your code itself. But what Victoriametrics does is that it allows ability to have dynamic histograms, so dynamic buckets. So let's say one of a page takes like 3 seconds to sort of load now. So you will have buckets ranging from 0 to 500 milliseconds, 500 to 1, 1 to 3, and 3 plus, and so on and so forth. But tomorrow, if something changes in your website and now the average time has increased to 6 to 7 seconds, let's say, but you want to exactly pinpoint whether it's 6 seconds, 7 seconds, or where does it lie. The problem with the Prometheus histogram approach will be that you'll have to go back to your code and rewire your buckets to accommodate and to basically do a sort of hit and trial where exactly your queries, where exactly your most of the data points are sitting in, and you have to basically change the code and rerun your metrics on that. But with Victoriametrics, they make it possible to have dynamic buckets. So that's pretty cool. Apart from that, this is the metrics exporter library. So Victoriametrics provides a metrics exporter for Golang, and on the right hand side you can see the same like the library for by Prometheus for metrics exporter in Golang. So the comparison I'm doing here is the number of dependencies it requires to pull in your code. So these metrics exporter are embedded in your main applications. Now, if the downsides of this is that your application binary size might increase, or you pull in extra dependencies, so your build time in the CI/CDs increase, and all of that. So, but with that being said, if you really need like all the features that Prometheus library provides, then you have no other option but to use it. But in my experience, like for our 90 to 95% of use case was covered by the Victoriametrics exporter library itself. So we never felt the need for the official client library and pulling all of those dependencies. So there's that. One thing is there, like I told, Victoriametrics provides some extra things on top of PromQL. So it's basically called MetricsQL. So this with template is also an example of syntactic sugar, basically, where you can see the first one is a pretty common node exporter query for finding out what percentage of your memory is utilized. So you can see the instance, node, port, job, all these filters are like standard across these metrics. So what we do is we just have templated out as a common filter kind of thing, and run your query on this. So if you run this on Victoriametrics, it will execute and show you the result, but it won't show you the result because this is not a PromQL supported query. So if you decide to use something like this, the drawback is that you cannot record rules. So yeah, so Victoriametrics, if you decide to use all these features that MetricsQL provides, you lose out the performance benefits of what Prometheus provides in recording rules. So you have to keep that in mind. Yeah, so alerting. So as of now, Victoriametrics doesn't have any support for alerting, and I'm not sure about whether it plans to have or not. So what we decided to do was we added a single like a set of three alert manager clusters, because alert manager has the capability to pair with its cluster dependencies, and we connect all of those Prometheus instances to this single alert manager cluster where all the deduplication of alerts happen, and from that we push out email and chat. So one thing, if you're considering Thanos versus Victoriametrics, you have to see that Thanos provides a ruler component which has capability of recording Prometheus rules and alerting on that, but Victoriametrics doesn't. So if that is something that bothers you, it's something to keep in your mind during the evaluation process. This monitoring, so you can see what I want to show is here that the data source type is Prometheus, and I give the Victoriametrics endpoint. So basically, a drop-in replacement for Prometheus data source in Grafana, like 99.9%. The 0.1% if you excluding all the MetricsQL queries. So this is some graphs from our production cluster. You can see that this is the CPU utilization and memory utilization stacked across all of the nodes in the cluster. And these are multiple clusters. These are not just single cluster. So we are getting the data from all the clusters together. One common pitfall I want to share in this slide, in this presentation, is that it's a very common mistake to have duplicated metrics if you have high availability enabled on Prometheus. So what I mean by that is, if you have single cluster and you run let's say two Prometheus replicas, and you push out the data to Victoriametrics. Now the Prometheus operator, what it does is it has a Prometheus replica field. So you can see the highlighted part, replica A and replica B. Now Victoriametrics understands these as two different metrics. So the implication of that is that on the first graph, you can see the replica A, and the second you can see replica B. So that is there. And when you try to do a sum on that metric endpoint, you basically see the twice the value of the actual value. So basically, you are seeing the wrong data here. The way around is that you have to deduplicate the metrics. So there are different approaches to that. The simplest one is that if you start your Prometheus replicas without this field, the Prometheus replica A, replica B, both of them will show the correct data. And Victoriametrics has the capability to deduplicate at its ingesting end. So you can see if you start with dedupe minimum skip interval, you can say that Victoriametrics will basically in that amount of time it will just deduplicate those metrics. So this is one of the simplest method, and I chose this because I really didn't care where which replica my data came from. As long as it comes to me, it's well and good. So I didn't need to identify the Prometheus replica on my Victoriametrics cluster. So this approach worked for me. Otherwise, you can take a look at this project called PromXE, which does a lot of more deduplication capabilities. And if so, basically, this was all about my experience with Victoria Metrics. But I've seen some people struggle with Prometheus, deploying Prometheus and Kubernetes as well. And even I struggled when I was just installing and testing out. Like there are just way too many ways to deploy and get started with Prometheus and Kubernetes. So one is the standard vanilla deployment. One is the other is the operator, which is by CoreOS Prometheus operator. So if you decide to do one of that, you also get different choices like Helm chart or the there's another project Cube Prometheus which uses JSON and all of that. So I'll just talk about what worked for me and what I wanted to have in this sort of solution. I wanted to have consistent uniform manifests across monitoring manifests across my clusters. So basically an ability where I could just do a kubectl apply and it should just work in each cluster, and it should all be same. Like my Prometheus version should be same, my configuration should be same, everything should be consistent across my clusters. So that was one of the biggest uh, key point for me to decide. And the other was, yeah, so when I was deciding between vanilla deployment and operator, this slide pretty much tells you why you should just use operator and be done with it. The left hand side is the Prometheus configuration to scrape a Kubernetes service object. The right hand side is doing the same thing but using the operator, using the custom resource definition, which is service monitor. So using the CRD, we do the same thing, but in like just probably 10 lines of YAML versus the kind of thing you have to write for doing the same, like probably 5 times longer. And you have to do this for each service. So it's not just one service, you have to do it for each service. And as you know, in Kubernetes, the services, as you have more and more deployments, the services, you'll have to keep on adding more services. So I really wanted to offload this task to the developers only so that they only monitor their service. So it kind of made sense to have a service monitor itself. So that's why straight out of the bat, vanilla deployment was uh, out of my process. But even if still someone wants to go ahead with that, the pros of that, I can just tell you quickly, is that you'll have a full control of resource type of what you're deploying in Kubernetes. So operator deploys a stateful set in Prometheus, but let's say for some reason you wanted a deployment object, you can control all of that. And someday if Prometheus changes its configuration, you can basically change your configuration on day zero when Prometheus changes it. So basically, you don't have to wait for the operator to incorporate all of those changes in the CRD, and you can have that advantage if it matters to you. Um, but the cons were more than the pros, so I removed vanilla deployment from my process. And yeah,
Take one quick time check. We have 5 more minutes, maybe.
yeah, sure.
Thank you.
So um, this is all about yeah. So in the basically just to conclude, I used customize for my deployment. This is the base monitoring config I have, and customize provides something called as patch. So I can have patch for each cluster where you can see I'm changing the replica on the right hand side The default is 2. I'm changing it to 3. So I can just do these patches which require minor bit of configuration in each cluster. So I can just apply to my base and just have a consistent configuration, but with some tweaking if a cluster requires. And pretty much that brings me to the end that what I wanted to achieve was a consistent monitoring stack. And basically, whenever the new cluster is deployed, I can immediately see those metrics in my Grafana visualization, the dashboards and all. So I was able to achieve that. And it's all possible because of the open source, all of the good open source communities we have. Firstly, Prometheus, which includes an alert manager as well, and then Grafana project. Victoriametrics is as well open source, and CoreOS, Prometheus operator, and Prometheus. These were the very uh, essential in helping me set up all of this from scratch, basically. So yeah, that's it. Thanks.